All right, guys, happy Friday. Welcome to 4-4. We're going to talk about altitudes, medians, and perpendicular bisectors today. Your assignment is the worksheet 4-4 after this is done. That is a gold worksheet that should be in a stack by the window, on my desk by the window. And after this video, you guys should have class time to work on it. As always, please pause this video as needed so that you guys can copy notes. Please pause it as needed because I will go faster than you can probably write down. All right, let's get right into it. What is an altitude? You probably know what this is from what you know about a triangle, but we usually call it the height of a triangle, okay? Altitude is a segment that is drawn from a vertex perpendicular to the opposite side, okay? From a vertex perpendicular to the opposite side. So it's a segment that we're going to actually draw. If we're looking at this correctly, this is probably a 90-degree angle, right? So let's assume that that is. That would make this side already an altitude because it's a segment drawn from a vertex perpendicular to the opposite side. So to make that even more clear, if I'm going to draw it from that vertex and it's going to be perpendicular to this opposite side down here, then I would have to draw along this line, and that should make sense knowing that this is 90 degrees. Same thing if I'm talking about this vertex here. If I want to draw a line perpendicular to this opposite side, it would be along this line right here, and also that should make sense because it's a 90-degree angle, okay? However, when I draw from the other vertex here, I don't have the same idea, okay? Now I have to figure out, all right, where is it going to be perpendicular? And I have to do my best to draw a line so that it intersects the other side at 90 degrees, okay? This is called an altitude, all right? That's how we measure the height of a triangle. In 90-degree angles, in right triangles, when we have 90 degrees inside the triangle, those are going to be sides of the triangle. But if I have a triangle that is not a right triangle, then I get different things. Now I have to draw it perpendicular to the opposite vertex, and now that can look something very different, okay? So in right triangles, make sure you understand that it will be sides, and in non-right triangles, they won't be sides. In fact, sometimes you might actually have to extend a side in order to make a perpendicular, in order to make an altitude that is perpendicular to the opposite side, okay? So that would make this one the altitude, but it's not drawn within the triangle, okay? So that's the example of outside of the triangle altitude, okay? It's how we measure the height of a triangle. All right, moving on here. A median is a segment that is drawn from a vertex. Okay, so all of these so far are being drawn from a vertex to the opposite midpoint. Okay, this is different because we're not going perpendicular. We are trying to find the midpoint on the opposite side. So let's draw from this vertex first. All right, now my target has to be on the opposite midpoint. Now I'm just going to estimate where that is, and I'm going to say about right here. All right, so let's say that's the midpoint. This would then be my median from that vertex to the opposite midpoint, okay? If I want to go from this vertex, then I have to find the median over here, okay? So if I find the median over here, I'm going to estimate that, and my line would go there, all right? Lastly, if I want to go from that vertex, I would find the midpoint. I would say maybe it's about here. And that line, I know that's not straight, but that line would go through there. Notice that those lines all intersect at the same point. We're going to talk about that in a second, okay? But that is a median, okay? A segment that is drawn from a vertex to an opposite midpoint. Your homework is going to ask to sketch all of these, okay? It's going to ask you to sketch these. Okay. Moving on, perpendicular bisector. We actually already did this with a construction on the last test where I gave you a line segment and I asked you to use your compass to strike an arc above and below, right? And then do it on the opposite side. And then we said, well, that then will be the perpendicular bisector of that segment, okay? This is the same idea. A perpendicular bisegment is a line or array, a line segment or array that is perpendicular to a segment at its midpoint, all right? So this is different than the other ones where we were drawing them from a vertex. This is, all right, here's my triangle, and now I got to first find the midpoint, all right? So I'm going to say my midpoint is here. And if I draw a line perpendicular to this, maybe I'll get my line tool out here. If I draw a line perpendicular to this, maybe it'll look something like that, okay? Maybe I'll adjust this a little bit. I'll move that guy somewhere in there. All right, let's say that that's perpendicular. Now I'll do that again for the other one. I'll say that perpendicular looks like this, and I'll move it to about where I think the midpoint is over here. Probably there. And then I'll do the same thing for the other one. Okay, draw my line, make it perpendicular, and then I'll try to move it about the same spot. Okay. Now if you look, if I were to continue all of these lines, okay, they look like they're all heading for the same point. Okay. There is a certain truth about perpendicular bisectors of a triangle, medians of a triangle, and altitudes of a triangle. Okay. These lines are all concurrent. That means that they all intersect at the same point. Okay. All of these lines intersect at the same point. So get that down in your notes. Two or more lines that intersect at the same point are concurrent lines. Okay. So perpendicular bisectors, again, they go through a side of the triangle perpendicularly through the triangle's midpoint. Okay. And all of those lines, once you get all of those lines, they will intersect at the same point. Okay. Hopefully you can kind of see that that's going to happen probably somewhere around here if we continue those lines. All right. Again, your homework is going to ask you to construct or sketch all these. So if you don't have these down in your notes, please pause the video so that you can get them down. All right, moving on. Examples here. It says sketch altitudes and medians. So I'm going to go ahead and do that. Okay, altitudes. Remember, altitudes are the height of a triangle. All right. Now I know Jade is probably sitting there. He spelled height two different ways. All right. Well, sorry. Whatever. You guys know what I mean. Okay. So sketch the altitudes and medians. Altitude, remember, means height. And I know that if this is a right triangle, which is what it looks like, I know that my height is going to be along these two lines. Because remember, it goes from an opposite vertex perpendicularly to the opposite side. From an opposite vertex perpendicularly to the opposite side. And this is the only one that's not going to be along the line. From an opposite vertex, I'm going to try to do this the best I can, perpendicularly to the opposite side. Okay. Also notice all of these lines intersected right there. All of those altitudes are concurrent. They all intersect at that point. Even if it wasn't a right triangle, that would still happen. All right. So let's now do all the medians. Okay. Remember medians, if we go back, a median is a segment that is drawn from a vertex to the opposite midpoint. Okay. So from this vertex, and actually, let me clean this up a little bit. All right. Here we go. Now we're doing medians. Okay. From a vertex to the opposite midpoint, I would say the midpoint is about here. There it is. Midpoint of this side is about here. About there. Midpoint of this side is about here. There we go. Okay. Now my lines are a little bit off there, but I'm not drawing them super accurately. But again, you can see that these lines are also concurrent and they intersect at about the same point. Okay. All right. Now, last example we're going to do, and I'm going to let you guys get off to the races here on your homework. This is going to be a question that is going to be very similar to what you see in your homework as well. All right. So it's going to give you some conditions about this picture, and then it's going to say, all right, tell whether each statement is true or false. So our condition is DB is the perpendicular bisector of AC. So DB right here is the perpendicular bisector of AC. which means that this is 90. Ooh, I don't know what happened there. Which means that that angle right there is 90 degrees. And if it bisects AC, that means those two are the same. All right. So let's answer the questions. First question is AB here congruent or equal to BC? All right. Now, in order for this to be perpendicular, this triangle has to be isosceles. Because think about it. If I move this any amount of degree over here, my triangle now looks like this. And now those side lengths aren't the same, and I can't make a perpendicular line to that point anymore, D. Okay? So if this is going to be perpendicular, then those side lengths also have to be the same. So then, yes, I would say that that is true. Next question. Is angle A congruent to angle C? Well, if these two sides are congruent, then this triangle ABC is isosceles, and we know the isosceles triangle has base angles that are congruent. That is also true. Next question. Angle ABD, is that congruent to angle CBD? Well, if this is 90 degrees, right, and this angle is congruent to that angle, this angle is congruent to that angle, I can really say that I have side congruency with these two small triangles, which means that these remaining angles are also congruent. So that's true. Is dB an altitude? Okay. Well, an altitude measures the height of the triangle, okay, which means it goes from an opposite vertex perpendicularly down to the other side. If this is a perpendicular bisector, then that makes this an altitude. That is true. Is AC a median? Was AC the segment AC a median? Does it go from one side of the triangle to the medium of a midpoint? It does not. Okay, this goes from one side to the other. It doesn't go from one side to a midpoint on the other side. So that's false. Are the two small triangles congruent? Well, we said we had side angle side congruency, so that is also true. And is AD congruent to DC? Well, we said that it's a perpendicular bisector, and if DB is a perpendicular bisector, that means it cuts AC in half, so that is also true. Okay? You will have a question like that on your homework. If you'd like to review this portion of it, please go back and do so. Your homework is the worksheet, and I hope you guys have a great weekend. I will talk to you on Monday.